Hi everyone. In this 4-part video series, we will look at setting up a SQL Server replication instance on Amazon S3 using BryteFlow Ingest. BryteFlow Ingest is our automated super-fast CDC software that delivers ready-to-use updated data from transactional databases to AWS and Azure in real time without any coding. This is a part 1 of the video where you can learn how to connect your source database and destination database on Amazon S3 using BryteFlow Ingest. So this is the BryteFlow Ingest software, which is the CDC solution for replicating your data onto Amazon S3 and all the AWS destinations. So we'll see how quick and easy it is to configure. All we need is to set up your source database, your destination database, and a few credentials. So a 3-step setup process, very easy and ready to go once you have all the setup done completely. So let's begin with the source database. So database type, as I said, it supports hundreds of sources. A few of them we can see here, which are Oracle, SQL Server, SAP, MySQL, MariaDB, SAP HANA, Postgres, Salesforce, or any other databases which it can do via JDBC. So any RDBMS database, any database which we can connect using JDBC. So the basic details required. So for today's demo, we are using SQL Server and the change tracking approach for the demo. And we have the SQL Server instance set up with the database details and credentials. So basic prerequisites required for if you're going for change tracking. The change tracking needs to be enabled on the source database and to give more detailed logging. So BryteFlow uses logs approach to get the changes in near real time. The impact on the source database is negligible for whatever approach is getting used, or even for Oracle or any other databases. So it uses the best approach to get the data onto the destination. Moving on to the destination database setup. So BryteFlow supports all of these destinations on AWS. First and foremost, S3 files. So for any of the S3 destinations, BryteFlow uses EMR. So S3 files using EMR. So when you want all your raw data to land onto S3, it will still need EMR. So you're building your data lake using the first option. By any chance, if you want the data to also be replicated to Redshift, so we have S3 files using EMR and load to Redshift option. So wherein your data, which is completely merged, ready to be used, it's landed on S3 as well as gets loaded onto Redshift as well. And the same thing for Athena. Your Athena tables are created and the data is already loaded onto the Athena tables. So you can straight away start querying your data onto all Redshift and Athena as well, along with S3. So all we need to set up is we are going to use EMR and Athena as a destination. So you need to provide your Athena database name, your bucket details, so bucket name, your Amazon S3 bucket name, your data directory where your final data is going to be uploaded, and a staging area. So Delta directory, it needs a staging area where the staging files will be uploaded, and an EMR instance needed as well. So for EMR, you need to bring up the cluster and use the tag or the instance ID so that when the software is doing the upload onto S3, It can use the EMR from this configuration and do the processing, do the complete merge, and give you the final output. For S3 and EMR, there are some additional permissions that it will need. So let's talk about and see those permissions in detail.